Okay, so in keeping with similarity, today we need to talk about the corresponding parts of triangles. And I want you to notice that in these two triangles, we've got two different size triangles. We've got two triangles that are the same shape, all right? We've got triangles here that have what we call corresponding angles that are congruent, all right? And we have corresponding sides that are in proportion. So these are similar triangles. Now, what are corresponding parts? A corresponding part corresponding parts are parts that are in the same position relative to their individual figure, if you will, to that particular drawing. So here I've got two people up here. Does everybody know where their left arms are? Right here, right? There's this one's left arm. There's that one's left arm, right? Look at it. Imagine it's facing you.
Oh, yeah.
Yeah, imagine it's facing you, okay? So we're not looking at it from behind, we're looking at it from the front. Let me put some eyes on it. There we go. All right, so we're looking at it from the front. So everybody knows where everybody's left arm is. So those are, everyone's left arm correspond to each other. They are in, left arms are in the same position relative to those particular bodies. Everybody's left arm is in the same place. We would say that left arms are corresponding parts. Does that make sense? All right? Just like everybody's parts are corresponding parts. Eyes, all right? Now, when it comes to these triangles, these angles are going to correspond to one another. In other words, there are going to be angles. If these two triangles are similar, we're going to have angles that go together, that are pairs. How do we know if they're pairs or not? There are two ways to show it. One way is by using the arcs. See these little arcs? If there's three arcs, that tells you that those two angles go together. If there's two arcs, it tells you that those two angles go together. If there's one arc, those two angles go together. Another way to show it is like this. So if I have a triangle and I want to show that they're corresponding, you can put one little tick mark in there. I've used tick marks usually. All right. You can do these angles. You can put two tick marks. All right. So you can use either the little tick marks or the arcs. All right. It doesn't matter as long as you are showing which angles are the same. All right. Now the little tick marks and the little arc tell you that those angles are congruent. Congruent meaning that they are the same. All right. So corresponding angles. Let's list them. Okay, the corresponding angles are A and F. So we would say angle A and angle F. Look at the notation for angle. It's just drawing a little angle. Angle A and angle F. All right, so we already said what they are. Angle B and angle D. And angle C and E. So those are your corresponding angles. Again, we've got to know which angles correspond when we're dealing with similarity, because similar figures have corresponding angles that are congruent. So the ones that are congruent, that's how they correspond. All right, corresponding sides. Now, the corresponding sides have to do with, if you're going to determine what the corresponding sides are, you're going to use the angles to help you with this. So, let's name triangle ABC according to the order of the alphabet, right? So this would be, write this down, triangle ABC. All right? I don't have to name it ABC, but I'm naming it ABC just because that just makes sense, right? I could name it whatever order I wanted to. But whenever I name a triangle, the other triangle has to be listed in corresponding order to the original, to the first one. So if this one is ABC, what order do these have to be? Absolutely. F, D, E. Now, why? Because F goes with A, D goes with B, E goes with C. You have to list those letters according to what angle they go with. Have to list those angles according to what angle they go with. Okay? Now, because I know how this similarity statement is drawn, is written, now I can show which sides correspond. I really have to be very careful with this. I really need to know how these triangles are listed or written before I start doing corresponding sides. But here's how once it's listed, it's super easy. Alright. So, alright. Let's say AB. Let's start with AB since those are the first two letters. We would say that AB, and put a little bar on top, remember, because that's showing it's a segment. AB is a segment. It's a side. Alright. What side corresponds to AB? If you match up letters. FD. All you do is match up the letters. So AB and FD correspond. Okay, what about BC? Mm-hmm. So, all right. And then there's only one pair left. That is CA. These two go together. So CA and what? What? FE or EF. It doesn't matter. If you say either way, it's going to be right. So I'm going to say EF. We did it that way for the other one. Pen, so it won't cooperate. Okay? So CA and EF. So all we're doing is listing these pairs of sides according to how the triangles are named, how they're labeled. Naming the triangle is very important. We're going to name the triangle according to the corresponding angles. And then we can name the sides, the corresponding sides. So this is, guys, if y'all understand this concept, it's going to make geometry a whole lot easier from here on out. This is huge. Big, big deal. Yeah, go ahead. So, in finding x in this first pair of triangles, we're going to use our knowledge of corresponding parts. Now, it's not mystery which sides correspond when it comes to these two triangles. There are no letters up here, right? But by observation, we can make a good assumption as to which sides correspond to one another. All right? So, what sides correspond to one another? What does 8 go with? 4. And that means 12 has to go with x. So here's how we're going to do this. Since the corresponding sides are proportional, let's write that down before we actually do the problem. Corresponding sides of similar triangles. I'm just going to say polygons, because a polygon can be any shape like that. Corresponding sides of similar polygons are proportional. Did I say that they're the same?
No.
No, they're in proportion, which means we can set up a little equation to solve for an unknown side. So for this triangle, we're going to set up this equation. 12 over x equals 8 over 4. 12 over x equals 8 over 4. Now, I cannot put 12 over 4 because does 12 correspond to 4? No. We want to make our ratio, our fraction, based on the corresponding parts. So 12 corresponds to x, so I'm going to put 12 over x. Got to make a little fraction here. 8 corresponds to 4, so I'm going to put 8 over 4. Now, what I do to solve this is use the old cross multiplication process. Y'all remember that from middle school? Yes, you do. You know it, but you don't know it. Cross multiply. When I cross multiply, I'm going to get 12 times 4 is 48 equals 8x. And then what's the last step? Divide by 8. So what is x? X equals 6. Okay? X equals 6. So, it's simple. Set up your ratios. Ratios are just fractions. Set up your ratios between the corresponding parts. And once you do that, set those fractions equal to one another, cross multiply. It's so easy.
You doing some sheet on this today?
Yes, sir. Super easy. All right, let's do the same thing over here. Now look, these things aren't turned so that they're facing the same direction, but you should be able to determine what the corresponding parts are, right? So what corresponds to x? 5. So let's do x over 5 equals 6 over 4. Now, if I did 4 over 6, would that be okay?
Yes.
No, that would not be okay.
Okay, it's too big.
Exactly. Because he said, because we did this one first. Since we did x over 5 to start with, we have to do 6 over 4. Now, if we had done 5 over x, could we do 4 over 6? Yes. You have to be consistent. You have to do the same order each time. So now we can cross multiply. Cross multiply. X times 4 is 4x equals 6 times 5 is 30. Divide both sides by 4. You will have a calculator if you want to use it. When you plug that in, you get, let's see, you get 7.5, I believe. 7.5. Let's see. 30 divided by 8. You got it? 30 divided by 8, 7.5. By 4, that is. 30 divided by 4. All right. So, our answer is 7.5. No big deal. All right. This is pretty easy, right? Okay, let's go to another set of examples. All right, this time they give me one congruent angle, one pair of corresponding angles. Which two angles correspond? How do you know which ones correspond?
Cause the little angle thing.
Exactly. The little angle thing right here. Those are the angles that correspond. So, because of that, you know how you can set this stuff up. We know which sides correspond to one another because we know about this little angle thingy. Alright? So, we want to know what x is right here. So it's obvious which side goes with x. Which side goes with x? 10. Alright? Now, you say, I don't see it. Alright? Well, since you really can't cut out the paper and rotate it, alright, you've got to kind of do some visual rotations here to get this thing to look the way it, to look similar to one another. Alright? But if you just kind of know in relation to that angle where the pieces are, then it's not as bad. So first off, I know that x and 10 got to go together. Okay? So I'm going to put x over 10. All right, now here's how I get. I got a choice. I can use any of the other pairs of angles of sides. Sorry, but I think it'd be easiest to recognize that 10 is just across from x, right? And 8 is just across from 10, right? So let's do 10 over 8. Now understand, these are not the same 10s. They're not the same 10s. Even though they're both 10, they're not the same 10. They're not corresponding. Yes, sir. What's your question?
You said it don't matter if we put 10 over X.
Yes, it doesn't matter. As long as you are consistent. So if you do 10 over X, you got to do 8 over 10. Okay? Now, did I do that right or did I make a mistake?
You made a mistake.
How did I make a mistake? Where is the mistake?
Because the 10 supposed to be at the bottom.
Nope. I made a mistake right here. What's supposed to be there? The 4. Now, can you tell me why that 4 is supposed to be there?
If you turned it, it'd be in the same place as the 10.
Exactly. If you turned it, it would be in the same place as the 10. You see how it's tricky sometimes? You got to be careful. Now look, this is how you can tell. The X and the 10 are across from one another, but what's in between those? The angle. Is the angle in between 8 and 10? Nope. But it is between 4 and 10. So that's where you got to be careful. You got to make sure that angle is in the same position in both triangles and use the sides carefully. Alright, now we can cross multiply. So now we get 4x equals 100. 10 times 10 is 100. Divide by 4. So x is 25. You think somebody could easily make a mistake on that?
Yeah.
Oh yeah. Okay? Oh yeah. No doubt about it. That's why you got to be careful. Alright, let's take a look at this one.
I got it.
So, for this one, look. These two angles are the corresponding angles. So which triangle do you want to start with when it comes to writing our ratios?
8.
We'll start with x. Alright. X over what?
18.
Over 18. That's pretty clear. That's obvious. Because if these were right triangles, which we don't know if they are or not, but if they were, the x and the 18 would be your hypotenuse. Okay? Now, x over 18. Does it matter which of these sides that I use?
No.
No? What do you want to use? 10? He says 10 and 15. Is he right? Yes. Why is he right?
Because it's between the angles.
Exactly. The angle is between those two sides. The angle is between those two sides. Alright? So it's all about being in the right position. Like, you know, if Jeremiah, stand up, Jeremiah. If Jeremiah stands up and he faces that way, face that way, and I face this way, lift your left arm. Are they matching up in terms of the direction they're pointed? No, the direction they're pointing. Is his arm pointing the same direction as my arm?
Oh, I thought we did
No. But are they still corresponding parts? Yes. Okay? So just because they're not pointed the same direction doesn't mean they're not corresponding parts. You just got to figure that part out. Which way that they're pointing, how are they related?
Good morning, Irwin County High School.
So,
Today is Thursday,
15x
2017.
equals 180.
And join me in the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America.
All right. So over here on the left, the top left. All right. Kind of hard to see. The angle that has one arc is right here. Might want to just kind of fill that in. See what I just did? I just put the little arc right there. Now you can set that up, but we're also missing a side over there, and so we need to put something over there. Let's put 6 right here on this side. Now we've got what we need to find x. Everybody see that? All right, over here on this triangle, again, this is the angle that's missing right there. And we need to have the side. The missing side is going to be right here, and we're going to call it, let's see here. Let's go with a 10. Okay. All right, now, y'all see that? This is a 10 right here. Now, you're probably going to get some decimals on this. That's okay. You'll need your calculator. All right, let's look at the next one. This one over here to the right, number 2. I think everybody should see what's there. The letter numbers are kind of small, but you can see everything on that. On this last one, number 3, which is right here. Okay, I think everything is there that needs to be. We don't really need this side right here, so these are the only ones that we need. But you got to do it according to the corresponding angles. All right, making sure that you are in the same order and being consistent with your fractions. All right, so go ahead and start working on those few problems, and then just a minute we will go over those, and then we'll start talking about something other things. Rev, you want one more? Yes, sir. While y'all are working on those, I'm going to try to finish up the test real quick. Princess, you want to come finish it?
No. It's 1, 2, 3, 4, 5. 5 on top.
I woke up. I woke up about 5:30.
Do 5:30 when we see that tip. You got around it. We ain't got it.
You don't have to around here. What you eat? Oh, I'm gonna eat. Okay, I can eat. I can eat. And I did see that. I sat on it and I put it out. I took it out first. You like forget it. See, move. I took it out first. I put it in the I can't buy it. $10,000. I was on it. Messing with it. Candy. I'm doing very good.
got those done? All right, let's go over those. I got your test graded. I'll show you in just a minute. I just got to put the grades on them. All right. So we take a look at this first one. Look and see how the sides correspond, or how the angles correspond. It's pretty obvious they're facing the same direction. So how would I set this first one up?
6 over 10.
Let me put it down.
6 over 6.
6 over x equals,
9 over 15.
okay,
Then you look at 10.
all right, 9x equals, let's see,
So when you gotta get
45,
on
90,
it,
x equals 10. X can be on top sometimes. Just depends on what you want to start with, as long as you're consistent. All right, let's do this one down here.
X over 10.
So he says x over 10. Now, you can do that. You can stay within the same triangle. I'm glad you said that. He said x over 10. Now, normally we do it where you take the corresponding sides and put them over each other, right? But it is okay to stay within the same triangle for your ratio. So I could say x over 10. This the x? That's 8 over 10. Oh, I'm sorry. I was thinking that was the 8. Never mind. Forget about it. All right. But what I was saying is true, but I was looking at the wrong thing. All
So on
right.
that
X over 10.
On that first
Yeah.
one, you said, what if you put X on top?
You can do x over 6 and 15 over 9. So as long as you're consistent, you can do, you put it on the top or the bottom. That's up to you as long as you, if you start with that triangle, you have to start the second ratio with that triangle also. All right, so you said x over 10, and then what?
14 over 8.
14 over 8. It makes it easy when you've only got the two sides, right? Because you only got two choices.
I got 17.5.
All right, so 8x equals 140. Divide by 8, x equals 17.5. Okay, you can put the 10 up here. You can put 17.5 there. All right. Any questions on those so far? All right, now it gets a little bit more tricky when you've got more than one. You've got three sides that you're dealing with, so you got to be really careful with these angles. All right, so notice that the 10 and the x, they are making this angle. Those are the sides that make the angle. So which sides over here make the angle?
35, 28.
35 and 28. But we got to make sure we go put the x with the correct side. Which one does x go with? 28. It goes to 28. So x over 28. Now, how do we know it goes with 28? Exactly. If you flip this thing over, the 28 and the x are in the same position relative to that angle, to the corresponding angles. All right, so then what's next?
6 over 21.
All right, you can do 6 over 21. All
10.
right, either way. Either way. Now look, here's the thing. But you got to be careful now. If you do x over 28, I got to do 6 over 21 or 10 over 35. Can't do 35 over 10. Right? Y'all understand why? All right, so here's the thing. If you start, look, if you say, I'm going to start with this triangle, you got to keep starting with that triangle. So if you say x over 28, then you still got to say, now you've got to come back and say 6 over 21 or 10 over 35. You see how I'm starting with this triangle when I do my fractions? I can't start with the other triangle and put that value on top of the second fraction. You got to be consistent. So if I think about when you're dealing cards, right? Y'all play cards? Right? If I start dealing with Jeremiah, the second round, I have to also start with Jeremiah. I can't just start with Chris because I want to. You got to start with the same person every round that you do it. Same thing here. If I start in this left triangle, I have to keep coming back to that left triangle when I do my next fraction. So he said 6 over 21. You could have also done 10 over 35. All right, so now we do 21x equals 28 times 6, 80. Oh, it's going to be 8, but what is 28 times 6?
28 times 6 is
168, I think. 28 times 6? 168. All right, divide that by 21, and you're right, it does come out to be 8.
I got it right.
Good. All right, so x is 8.
So if you did 10 over 35, you would still come out?
Yes, sir.
Okay.
Yep.
So the answer would be the same?
Answer will be the same, because these sometimes actually, you can set up an extended proportion, all right, where I could actually set this equal to 10 over 35. I wouldn't want to do that. I don't need to do that, but it's also equal to 10 over 35. So that means that whether I put 6 over 21 or 10 over 35, it's going to still give me 8. Because if I reduce 6 over 21, if I divide 6 and 21 by 3, I get 2 over 7. If I divide 10 and 35 by 5, I get 2 over 7. So in reality, it's the same fraction, just different forms of it. All right, let's look at number 4. All right, so what's the first ratio that you want to use? 7 over 16?
X over 16.
X over 16, okay. Now, why did you use x over 16 instead of like 6 over 16?
Like when I happen to I flip it, it's just like the angle being the same spot. So
Exactly. All right. Now, look at x and look at the angle that it's across from. If you imagine there's a flashlight in this angle, which side would it be shining on? It would be shining on x, right? So if you look at this angle and put a flashlight in this angle, what side is it going to be shining on? 16. So that means x and 16 go together. So x over 16. I love to use the flashlight. I call it the flashlight rule. All right. If you want to know what side is across from an angle, think about a flashlight. Put a flashlight at that angle and shine it. It's always going to shine on the side that's across from it, right? So the side that's across from the angle is x. The side that's across from this angle, 16. So x over 16. All right. Now, then you got to be careful. All right. Am I going to use 6 and 20 or 6 and 12? 6 and what? 12. Think about it this way. Notice, think about a map like it's a map. If this 6 runs into the side with x, it makes almost a right angle, right? Well, which side over here makes a right angle? Right here. If I were to use 20, it doesn't run into a side that makes a right angle. All right, so 6 runs into x the same way as 12 runs into 16. Does that make sense? So we're going to use 6 and 16. Got 6 and 12, sorry. So you got to be careful. Got to be careful. Now, here's a good way to check yourself. When you find your final answer, the final answer here, 12x equals 96, x equals 8. When you find your final answer, put it back in there for x, and then reduce it. What is 8 over 16? 1/2. Remember, you're going to divide top and bottom by 8. So anyway, it reduces to 1/2. Well, what does 6 over 12 reduce to? 1/2. If you did, instead of 12, if you had done 20, it's not going to work out right. Well, it might accidentally work out right, but you want those ratios to be the same. Yes, sir? 96 because 6 times 16. Cross multiply. That's good. That's good. All right. So we got one problem left over here. And I didn't give you the angle over the side over here because we really don't need it. Don't even look at the 33. We don't need it. All right. So he says x over 21, and then what? All right, now how did you know it was going to be x over 21 instead of x over 30?
You see them two, see two.
These right here?
Line up, they bet line up.
Okay. All right, however it works for you. These sides are in the same position relative to their angles.
I thought you were supposed to put it, never mind, it's not right.
Okay? So notice that both of the, if you start at these angles, all right, and you run to the top, they're running in the same way. Okay? So that would leave 10 over 30. And so when you cross multiply, you get 30x equals 210. Divide by 30, and what do you get? X equals 7. Okay? All right. We're going to skip these next ones because some parts got cut off. I don't really know how they wanted to do that one. All right. So, Princess, you about done with that thing? You got a few left. Just keep working. Keep working. All right. Now,
Wait one moment.